Okay, let me show you a little bit about solving absolute value equations and also inequalities. So let's start off with what we'll say is an equality. So if you had the problem x minus 5, the absolute value of that equals 7. Okay? And the absolute value means that whatever is in here could be equal to 7, or whatever is in here could be equal to negative 7, because if I take the absolute value of negative 7, I'm also going to get 7. So both of these options are valid. And so what we do with absolute value equalities is you turn it into two problems. The first problem is as written. The second problem is where you change the sign from a positive 7, in this case, to a negative 7. And then we just solve those using our normal algebra. We add 5 to both sides and we get x equals 12. And then we do plus 5 and we get x equals negative 2. And we have two answers. Now if we actually go back and check our work, if we put x equals 12 back in here, the original equation, we get 12 minus 5 is 7. The absolute value of 7 is in fact 7. So this is valid. If we go ahead and put negative 2 back into our original equation, negative 2 minus 5 is negative 7. The absolute value of negative 7 is positive 7. So we just verified by checking that both of these values of x do in fact satisfy the equation. Always a good idea to go back and check your work. Let's try another equality, but one that has a unique characteristic to it. I gave you 2x plus 12, absolute value equals 4x. We're going to do the exact same thing we did before. We're going to turn it into two different problems. So it'll be 2x plus 12 equals 4x, which is as the problem was presented originally, and then we're going to do 2x plus 12 equals negative 4x, which is taking the opposite. And we're going to do our algebra. We're going to get 12 equals 2x by moving the 2x over. We're going to get x equals 6. And on this one, we'll move the 2x over. We'll get 12 equals negative 6x, x equals negative 2. And we have to go back and check our answers. When I put 6 back in for x, I get 2 times 6 is 12. 12 plus 12 is 24. The absolute value of 24 equals 4 times 6 is 24. 24 equals 24. So this one is fine, no problem. Check. When I put negative 2 back in, I get 2 times negative 2 is negative 4. Negative 4 plus 12 is 8. So I get the absolute value of 8 equals 4 times negative 2. Again, I'm substituting x equals negative 2. And this is not a true statement. Okay, 8 and negative 8 are not the same. We call x equals negative 2 extraneous. It's extraneous because algebraically we derived it as a valid solution. But when we plugged it back in, we realized it's not valid. And the reason is because the absolute value can never be negative. Okay, so I can never have a negative number here on the right side, okay, because absolute value is always going to force my answer positive. So the point here is you should always check your answers, particularly when the right side of the equation has a variable in it. That could introduce this case where when you solve it algebraically, you get an answer that when you plug it back into the original, it's no longer valid, and we'll call that extraneous. So be mindful of that. Let me do absolute value inequality. If I have 4x plus 5, absolute value is greater than 13. Okay, now in this case, we're still going to turn it into two problems, just like we did for the equality. The first one is going to be as written, but the second one, what we're going to do is we're going to flip the inequality sign from greater than to less than, and we're going to change the sign on our answer to be negative 13. So you're changing two things with the inequality. In the case of the equality, we rewrote it twice. Once as written, once where we just changed this from a positive to a negative. But with the inequality, you're changing two things. You're going to change the sign, the inequality sign, and you're going to change the sign on the answer, in this case from a positive 13 to a negative. Then you're going to solve these as two completely separate problems. 4x is greater than 8 by subtracting 5 from both sides, and x is greater than 2. On this side, we're going to move the 5 over. We're going to get 4x is less than negative 18, and x is less than negative 18 over 4. which means x is less than 9, negative 9 halves when I simplify a fraction. Okay, so I have two answers. Then what I'm going to do is I'm going to go ahead and graph it. Here's my 0, here's my 2, here's my negative 9 halves. Okay? And in this case, what we have here is x is greater than 2. Just like before, we put a circle over the 2 and we shade greater than. Okay? And then we have x is less than negative 9 halves, which means we're going to open this up as well. Okay? And we're going to shade less than, which is in this direction. So there's your graph, and here's your solution. Okay, so the key here again is to remember with inequality absolute value, two equations, flip the sign, or the inequality symbol and the sign on the answer, just like we did here, and then solve independently. In the case of inequality, go ahead and write the problem as presented, write it again, where it's a negative, in this case 7, solve it as two independent equations. And there you go, you take your answer, and that's how you'll present it. Good luck.